No
I'm
problem.
okay. It's okay. I think time
Okay,
is yours. Yeah.
cool. All right. Good afternoon, everyone. My name is Marielle, and I'll be doing a presentation on data science ethics. Wait, let me share my screen. Right. So let me click that. And yeah, so I was thinking of making this presentation a bit more interactive and hopefully a bit more practical, since data science ethics is such a broad topic, and it sometimes can seem a little abstract because many of many of the kind of the ethics violations that are made by companies who do data science and machine learning, we hear about it in the news, and by then it's already too late. Um, like for instance, like women are not granted for some reason credit, are not given credit cards by their banks because they were flagged as high risk clients by the bank, for example, only by virtue of them being female, or in the US, Black people are predicted to be more likely to recommit a crime if they were released from prison, that sort of thing. And it's good to hear about these negative repercussions of doing data science and machine learning without paying attention to ethics. But for this presentation, I'd like it to be more about the things that you can control from the very beginning of your data science projects, so that you don't actually arrive at a kind of slippery slope. So like you just don't arrive at that kind of difficult situation down the road, and that you can prevent them from happening in the first place. So yeah. So I mentioned at the start of the week that data science is a science, which is a fact that a lot of people tend to forget when they work in data science. Yeah, I have a question for the audience, and the question is, what sets science, just science in general, what sets science apart from pseudoscience, from not science? I'll maybe give you about 30 seconds to type in the chat maybe your ideas or answers to this question, and your kind of opinions on what makes science a science, and how does it compare to not sciences. Yep, just type your ideas in the chat and I'll read them out loud. Anyone? Okay, so maybe we can pick up that discussion a little later. Okay, well, someone wrote here, using proof to make conclusions. Yeah, and what makes up that proof is probably data. And how do you arrive at that proof? Well, science involves the scientific method, which I suppose we all learned from a young age from school, right? And yeah, the science, like fields that involve science, they go through a specific logical step-by-step method to arrive at conclusions. And it, in general, follows this flow where a scientist observes a phenomenon or identifies a problem. And then the scientist will make a hypothesis about that, about what they've observed, about a problem that they're trying to solve. And from there, they test their hypothesis by collecting data, by doing experiments, and then they analyze their data, they analyze their results, and then they report on the results. And then hopefully other scientists who find that these studies or these results are interesting, they will try to replicate that result. And so so sciences tend to follow this more or less the same method, because it's not It's not like other fields. It's not like the arts where a lot of emotions and subjective experiences and opinions are more important than, say, collecting data and going through a rigorous analysis process before concluding something. So in non-sciences, technically everything can be correct. But in science, if you don't go through this methodological, if you don't go through the scientific method, then your results or what you're saying to be true is not in fact true. And I'd like to think that data science is a science because it follows this rigorous step-by-step procedure, and that opinions and subjective experiences matter less when it comes to machine learning applications that basically rule our lives on a daily basis. So what I'd like to emphasize in this talk is that data science, that as data scientists, you must act responsibly when you plan your projects and when you analyze your data. You must act responsibly and follow the scientific method as close as possible, and not rely on guesses and not rely on opinions. So for instance, we as data scientists use Python mostly, and other computer languages like SQL to do stuff. But coding is only a technique to get us to where we want to be with our data, which is, if you work for a business, that is, getting data insights from your data. And so don't mistake the technique for being everything that data science is about. The technique is only one way, it was only one tool to get to those data-driven insights that we all want from our data, that we all want from our machine learning solutions. It is coding, Python, and all that is just the tool. And critical thinking, in my opinion, is much more important if you want to build a career in data science, because it's the one thing, your ability to think critically is the one thing that machines can't replicate. It's the thing that makes you unique. And you have to be critical about every decision that you make at every step of the data science process. That's from picking the questions that you'd like to answer using data science methods, or picking the features that you would like to put in your model. And the conclusions and how you interpret your data, which metrics do you use? I think you experienced a little bit of that this week. All of those steps need your critical thinking. And in a way, those are the things that you can't automate, and those that will make you invaluable in the job market. Another thing that you shouldn't take for granted is that your predictions, that the things that you come up with, based on your analysis, based on the machine learning models that you've built, they must be useful for your stakeholders. Stakeholders here could mean, if you're working for a company, it's the clients or the customers, or for example, if you're building a machine learning model for an app, these are the users of the app. Those are your stakeholders. Or if you are helping the sales team of your company to maximize lead generation, for example, then your machine learning solutions must make the sales team happy. It should meet their needs and it should be useful for them. Data scientists are very passionate and curious people, but on the flip side, maybe a lot of the things that we find interesting might not have a lot of value for people that we want to help or that we say we would like to help. So it's good to involve all of your stakeholders when you're planning your data science projects to make sure that what you're doing is relevant. And your work should avoid causing harm to people. You should be mindful, and you should try your best to make sure that any machine learning solutions that you make will not, for instance, disproportionately affect or prefer males over females, for example, or prefer people from a high income bracket than people from a low income bracket. And to do that, you need your critical thinking, as I said. And so I'd like to do an exercise with you all today. So I will be asking some questions to that will require critical thinking. I have 5 questions that I've prepared 5 questions, and they have to do with, they're related to feature selection. So as you know, that when we design a machine learning model, we have to select input data or features that would predict an output. So this is for supervised machine learning. So I will ask these 5 questions one by one, and I'd like you to answer them in private. Just kind of take a pen and paper and write your answers down. And then after I ask all of the questions, I will I will ask you to post your answers in the chat, and then we can discuss your answers together. And what I believe is the right answer to the questions. And so I'll give about maybe a minute to 30 seconds for you to like answer each question. So yeah, so grab a pen and paper and let's start. So question 1 has to do with job salary. So let's pretend that you're a data scientist at a company, and your task is to predict the annual salary of employees. And so you were given this data set. So the data set has these 6 columns. So you have the employee number, the years of experience for each employee, you have the monthly salary, you have the highest education level that employee has achieved, and their position within the company. And your task is to predict annual salary, right? So based on this data set, which features would you use? So which features would you use to predict annual salary? Would you use all or just some? And if your answer is some, then yeah, which of these features would you use? So I'll give you a few seconds to a minute to answer that question, just on your own. About 10 more seconds. So the 6 features are, well, so this is the target, so the annual salary, and the 6 features are the other columns, basically. Employee number, years of experience, monthly salary, education, and position in the company. Can you maybe, in the chat, let me know if you're ready to move on, or if you need a bit more clarification? So you're meant to answer the questions in private first, and then we will like, share our answers in the chat after all the questions have been asked. So now I'm just asking if we're on. Okay, well, I guess we should like, be ready to move on. Cool. So the next question would then be another scenario. So all of the questions have to do with like a scenario of some sort. So in this time, your task is to predict the likelihood of a bank customer paying back a loan that they've taken out from a bank. So you're given a data set, and the data set is made up of borrower ID, so a unique ID for each customer of the bank, how old the bank customer is here, and their monthly salary, and whether they received a late payment reminder or not. And so your task here is to predict whether they would be likely to make a late payment. So that means they borrowed money and then they didn't pay it back until after the deadline that the bank gave them, right? So it's the same question as question 1. Which features would you use from this data set to predict late payment? So the features that you could choose are either borrower ID, age, monthly salary, or late payment reminder. So out of these columns, which ones would you use as your features? Okay. Cool. So we should move on. Okay, so in this question, the scenario is your task this time as a data scientist is to predict the likelihood of a flight being delayed. So back pre-COVID, we used to travel by plane. And one of the most annoying things about traveling by plane is that there are flight delays. I think it's one of the most annoying things about traveling, like using any vehicle, really. But I think even more so with airport delays, right? So for this task, you were given access to a large database of flight delays from 1987 until last year, 2019. So out of this vast amount of data of flight delays from 1987 to 2019, which of the data sets would you use for your analysis? Will you use all data sets from 1987 until 2019 to create a machine learning model to predict flight delays, or will you just use a portion of that? So give you a few seconds to think about that question. Cool. So question number 4. In this scenario, your task is to predict whether a book, so for example, you work for a publisher and the publisher is about to release a new book. Your task is to predict whether a book will be well liked by readers. And so to do this task, you use a data set from Amazon. So you use a data set of Amazon reviews for similar books. I'm sorry about that. So you take a similar book and then you collect the reviews for that book, and then you would like to predict whether readers like that book or not. So here's kind of like a breakdown of those customer reviews for that book, where you have about 66% of readers rated the book with 5 stars. About 6% 4 stars, 3% 3 stars, 6%, 2 stars, 7%, and 1 star, 15% of the readers didn't like the book at all. So what kind of problems do you foresee with a data set like this? If you were given a task to predict the likelihood of a book being well liked, what kind of problems do you foresee with a data set that looks something like this? Okay. And for the last scenario, for the last question, your task, or well, what your project is creating a machine learning model that predicts how much a customer likes a brand, but based on their age. So basically, the model predicts whether someone likes a particular brand based on how old they are. So you were given a data set again with customer IDs. So that's a unique ID to identify each customer. And then you have the customer's age. And you have brand ratings from a scale of 1 to 5. And so you see here how much they like the brand or not. So for this customer, they gave it a score of 5, which means they really like the brand. This person gave it a 2, which means that, yeah, they like the brand a little less. And then this customer liked it, gave the brand the rating 4, which means that they quite like the brand, right? So assume that you have this machine learning model. What problems do you foresee if you use the exact same model to predict brand preference or brand, brand appreciation, let's say? What do you foresee? What problems do you foresee if the same exact model were used in 10 years? So give you a bit of time to think about that. Cool. So at this point, please type your answer in the chat. Just, yeah, whatever. If you weren't able to answer all the questions, that's perfectly fine. Just enter, the answers that you came up with in any of like the questions. So I'll give you, a few minutes to kind of think about that. Think about your answers and to share them to the group. So no one's shared their answers yet. Is there a problem maybe with either with any of the questions, or because it's really hard to run a tutorial if you don't really get any feedback. So maybe someone can speak up and unmute themselves and say something.
We didn't really write. I hadn't written the answers in the chat. I'd written them somewhere else. So
Okay.
can I read them? Is that okay? There is question. The first question: years of experience, education, and position.
Yeah.
And the second one.
Okay. Do you think so? Do you think it was too fast? What's that?
Yeah.
Do you mind?
All of them. I'll use it.
Sorry. Okay, so people are typing. I'm sorry, Kevin. It was a little loud. Yeah, so I'll go through the questions again really quickly. So for the first scenario, your task is to predict annual salary here. And so you have a choice between of features between these other columns. So employee number, years of experience, monthly salary, education, and position. So which one would you choose? So for the second question, your task is to predict the likelihood of a bank customer paying back their loan on time. So you have this column called late payment, and then you have these features: age, monthly salary, and payment reminder, which is the number of times that they were sent a reminder or a warning that they were paying their loans a little too late. Now, in the airport delay scenario, your task is to predict the likelihood of a flight being delayed. And for this project, you were given access to a huge database of flight delays. So you have many data sets and many data points that show the flight delays between 1987 and 2019, which was just last year. And which of these data sets would you use for your analysis? Okay. And so for the user reviews scenario, you are tasked to predict whether a new book is likely to be a successful book or a book that people will enjoy. And so to do this, since the book hasn't been released yet, you took a book that is very similar, and you looked at this book's reviews, and the breakdown of reviews for that book is as follows. So about 66% say that it's a 5-star book, and about 15% of readers say it's a 1-star book. So and the question is, what problems do you foresee if you have a data set like this? And lastly, for the user preferences scenario, you have a brand, and you would like to, and you created a machine learning model that predicts how the customers like that brand based on their age. And so what problems do you foresee if you were to use the exact same model in 10 years, if you were to still predict in 10 years the likelihood of a brand being liked based on age? Okay, so I'm scroll through the chat. Cool. So, given the specific parties. Cool. So we have some really good answers, and we have some points for discussion at this point. So we'll start with question 1, which was about job salary. And many of you have said that they would use a monthly salary to predict annual salary. And some of you have also said you would use all features. And yeah, mostly all. Yeah, cool. All right, so about job salary. So there is a concept in data science called data leakage, which means that your features are too similar to the target that you're trying to predict. So if you use monthly salary to predict annual salary, then your model would be able to predict annual salary perfectly, because monthly salary times 12 is just annual salary. So in fact, that you now have a machine learning model that is able to predict your target absolutely perfectly, but you didn't exactly learn anything from that information, right? It's in a way, it's very obvious that you didn't need to build a machine learning model to know that people who earn more on a monthly basis also earn more on an annual basis. What would be much more interesting and helpful here is maybe years of experience. Do people who have worked longer in the industry, do they earn more? Or do people with a higher education level do they learn? Do they earn more? So in general, in machine learning, you shouldn't pick features that are too similar to your target. Monthly salary is too similar to annual salary because it will give you models that are super perfect. They're just perfect, but it doesn't have a lot of substance because it's also in a way already an obvious thing that a high monthly salary means a high annual salary. So just be careful about choosing the right features for your machine learning model and making sure that you don't cause data leakage. So data leakage is a very interesting concept that I encourage you to read up on. So would you use all the features? Is a question that we just got in the chat. So you would not use all features. You could try, well, employee number is a unique number for each row. So that doesn't have any predictive value at all. But I would use maybe years of experience, education, and position, like their rank in the company, to predict annual salary, because just going by domain knowledge, in a way, we were all raised to value education. Like the higher educational attainment you have, the more chances you have of getting a high-paying job, for example. And so these are factors, and these are pieces of information that we know from domain knowledge, from just common knowledge, that they have an effect on annual salary, and that they are able to predict annual salary. So I would try those 3 features. Yes, a too perfect model is a problem because in general we want perfect models. We want models that have high accuracy. But if you have a high accuracy, you also have to be a little suspicious, because that means one of your features is really, really good at predicting your target, like really, really good. And it might make you suspicious that maybe the feature is also exactly the same as the target, right? So in the case of monthly salary and annual salary, these are exactly the same things, except that this one is annual salary divided by 12. So ideally, you need features that are informative and that will tell you something about the target, but is not exactly the same as the target. So, and data leakage, a very important machine learning concept, and I encourage everyone to read up on it. And I will probably share some resources on Slack about this. So for question 2, well, okay, sorry. We'll go through the chat first. Question 2. So someone said, I think Elvis said, borrower ID and month and late payment reminder would be the features they would choose. And yeah, people were saying all as well. They would choose all the features to predict the likelihood of making a late payment. And so this is funny because it's also a trick question, because so late payment reminder is that stores data of about how many times a person paid late, basically. So if you pay late, the bank will send you a reminder and say, you missed your deadline again, and you should probably pay us back. So basically, and the thing about that, this data can only be collected after someone has made a late payment. But the task that you're trying to achieve here is to predict the likelihood of late payment. So in a sense, this column comes after this. So if you don't make a late payment, then the value for this column will be 0, which means, or it will be missing. So if you choose features to include in your machine learning model, make sure that you can collect that data about the features before you can collect information about the target. So in a way, yeah, so in a way you can't use this column because the information for this column is not available. for certain customers, because some people, yeah, we don't know the likelihood of some people, we don't know the likelihood of people paying late. Yeah, from the number of reminders that they get. Sometimes, people who get, a lot of reminders happen to pay on time the next time. I hope that makes sense. But yeah, so basically you should have a think about whether these concepts, like whether the concepts related to your features come before or after the target that you're trying to predict. Actually, another example for that would be in the data set regarding flight delays, only because I've worked on a project like this before. When you get data about flight delays, so you'll have a column there that said whether the plane was delayed or not. And then there are other columns where the cause of delay was given. But what do you think is the value of that column if your flight was not delayed? There is no cause because your flight wasn't delayed. So, but because that information came after the target, was collected after the target was measured. So yeah. So with regards to airport delays, the task was to take a data set and select data from, is to get data from a database. And I think someone mentioned that they would take the years from 2009 and to 2019, which is the last 10 years, and over the last decade, which means, that's, I think, a pretty good, solid rationale, just getting the last 10 years. So some problems that I identified from maybe selecting all of the data from 1987 until 2019 is that, for example, in 2001, there was a terrorist attack in the US. And after that, basically airport security all over the world changed. And because airport security all over the world changed, the cause of delays have also changed, because a lot of airports now have to go through really, passengers have to go through a rigorous security check. And that causes delays. So the data about flight delays before 2001 is vastly different from the data in the present year. And even if you think about it, air travel in 2009 is also not the same as air travel in 2019. So you have to be careful about the data you select, because you have to remember that supervised machine learning is about using past data to predict the future. But you also have to be creative about what the future might look like, right? So I'm sure if there was a machine learning model predicting flight delays after 2020, if they use data from 2019, it might be completely irrelevant, because 2020, or if they use the data from 2020, it might be the model might be completely wrong, because air travel this year has just been vastly different from flight travel last year, meaning that there aren't that many commercial flights flying out of airports nowadays. And so for question number 4, it looks like a lot of people got this right. Let's say, so one answer here is that the data set here is not evenly distributed. And what else here? The data is not evenly distributed. A problem of generalization, given that there are no specific pointers as to why someone would give a certain rating. That's also true. And so online reviews is a very interesting data set to use for machine learning, because it tends to be very biased. So I don't know if you're the type to write reviews online, but usually the happiest customers and the unhappiest customers are the ones who write reviews online. And so if you go on Google and read a restaurant review, you'll see a lot of people praising a particular restaurant or completely slamming them because they had a really bad experience. So you should also be careful about using data sets like this, because you only get really a portion of the total number of people who go to a specific restaurant, or buy a certain brand or read a certain book. And it's usually just the happiest customers, the happiest readers, the happiest diners, and the unhappiest of them. So it's biased. So, and just be aware about that. Be aware of that and use that knowledge to your advantage when you're making conclusions. And so the final question, and it seems that a lot of people got this correct as well, or kind of, we're able to identify what the problem is, that after 10 years, the people who are 20 years old today will be different from the 20-year-olds in 10 years. Preferences change. So you have to be mindful about the features that you select and how they might change over time. So, for example, if you know Spotify, the music app, personally, like, I don't always use my Spotify, but maybe I used it a lot in 2016, and I was listening to a specific genre. Like, I think I was listening to a lot of jazz at the time. And whenever I open my app, it always, recommends jazz songs, which are still nice, but are not my favorite music genre anymore. So it's quite interesting, like, when machine learning models, they're so smart, but then they are unable to work with any data that isn't fed to that model. And machine learning models can't read our minds. So it's up to us as designers of these systems to be aware about how features will change over time. So I think someone else wrote, so this phenomenon is called concept drift. And this is not something that you can measure with statistics. This is something that you need domain knowledge for and critical thinking skills. Again, concept drift, which is why I put it in bold here, is a very interesting and important concept in machine learning. And you should look it up, and I'll share some resources about. So someone asked a question. So it's perfect to use 2009 and 2019 data for question number 3. Well, I think it wouldn't be a problem, massive problem, but to be safe, I would probably just use from the year before. For something that is so volatile as air traffic, I would try to use data that is as recent and as current as possible. That's just my opinion. So to conclude this session, I want to re-emphasize that data science is a science. And I'd like to share this quote that maybe some of you have heard before. It's by Abraham Maslow. He is a psychologist. I like him because I'm also a psychologist. And he said that if you only have, you tend to see every problem as a nail. And that is a quote that is used a lot in computer science to mean that there are certain favorite tools among computer science communities, and because it's such a favorite among a lot of in professional circles, people then tend to think that every problem can be solved using that tool. And in a way, data science is like that. Like, you think that everything can be solved with data science. Every available data set is a good data set to use for a machine learning model, and that is not true. You need your critical thinking skills to identify what data is appropriate and how that data might change over time. And again, I would try to build up these skills maybe even more than your coding skills, because your coding skills will catch up with you at some point. Like, you will be faced at work with a situation where you do have to learn the latest Python tools or something. But critical skills, that is harder to replicate, that is unique to you, and that will make you a better data scientist, and it will make you stand out. and it is not something that you can be taken away from you. So yes, I hope you learned something. And oh, that was my last slide. I hope you learned something. And I think is there still time for questions? If you have any questions, yeah, I'd love to answer them either now or on Slack. Jean, do you know if you can
Yeah,
stay?
so I think
Mhm.
I even like this one. Like, okay, so if you have any question, you can just ask here or on Slack. I'm here also, and so that was perfect tutorial, Marielle, and I want to
Mhm.
thank you. Yeah, thank you so much.
You're welcome. You're
Yeah.
welcome.
So, guys, I was telling you this one is more than Bayesian statistic. Did you get now? Yeah. Okay, so I
Okay,
think
I got.
there are some questions. Okay, some
Mhm.
people are asking some
Sure.
questions. You can look at the chat and
Mhm. Sure.
yeah.
Okay, so there's a question here. Can critical thinking be learned? Absolutely, it is a skill like any other. Um, I think it's a little harder to learn because there isn't a tutorial that you can like just look up on the internet. And it's not like Python where like you can follow the steps to get to where you want to be. I think critical thinking comes from experience, definitely. So your let's say your best bet if you want to build your critical thinking skills is to gain as much experience as possible. Um, or say read a lot of books and like develop the ability to ask the why question, like why, for example, if you read I don't know, a news article about this latest AI tool, you ask the questions why does this thing work that way? How is the machine able to predict, let's say, classic example, how is the machine able to predict spam in my inbox folder? So things like that, what features could they have used? Yeah, I think it's seeking out like appropriate experiences to apply critical thinking that will, get you further, and it will help you develop those skills.
Great. Thank
Um,
you, Marielle. And yeah,
mhm.
are you telling? Are you talking? So I wanted to conclude this. I don't know if Aaron has something to
Mhm.
say. Aaron? Yeah.
I think if there are questions, we can keep going, Marielle, if you have time.
Okay.
Yeah. Prosper asked a question. Can you share steps for a newbie without a data science or coding background to pursue a data science career? I think like being part of 10 Academy is a great start. I don't know if I mentioned it on Slack, but I have worked with a lot of data science newbies, and I've educated a lot of data science newbies as well. And I didn't always have a control over the lessons. Like I didn't always create the lessons myself. And it's the same case. It's the same here with 10 Academy. Like I didn't create the lessons myself, but I think it's one of the best that I've seen. Like I have never seen a beginner's course that involved Bayesian statistics, for example. So I think this is you're at a really good you're in a really good position, I would say, if you're already part of this community. And another thing that I would do alongside being involved in 10 Academy and taking the course seriously is to join community events as well. It's a little difficult now that there's a pandemic and all events are online. And sometimes it can get quite overwhelming, but I highly recommend that you check out your local Python community. So there's PyData, so that's, I'll type it out. PyData, that's a community for Python users, specifically those who use Python to do data analysis. There you can meet a lot of people who enjoy data science, even like as a hobby or or professionally, and you can get advice from people there. And most importantly, you can network as well with people that are that might be hiring. And there should be chapters, because it's a worldwide organization, and there should be chapters in your country of residence. And even if you can't meet in person, you can meet online. And there are a lot of virtual events as well for PyData. So you can try that. And also, if you're currently already working, even if you're not working as a data scientist, I would try to inject as much data science or as much Python in my day-to-day job as I can. So if, for example, at work, you already do visualizations for PowerPoint presentations. So instead of doing them on PowerPoint or on Word or whatever, try to do it on Python. Or if you have some data sets in Excel, try to migrate that to Pandas, for example. Try to find ways to make data science and Python relevant in your current situation, I think would be a good way to go.
Yeah, great. So any other question? I think we are done. I think we are done. So yeah.
Okay.
Okay. So I will stop the recording and okay. Okay, I think there is a question.
Okay. I just saw that. How should people make their decision when going into data science? When should someone go towards machine learning and other disciplines? I think so. Data science is a really broad field, and I think I mean I'm not sure if this is the answer that it would satisfy anyone, but like I think like whether or not you specialize in machine learning will come with experience, basically. So if you're still trying to break into data science, into a data career, you probably don't have that many options. And to say that I want to work on just machine learning, I want to work on just AI research, it'll come with experience because you might have interests now. Maybe you're drawn to more of the coding part of data science, or you're drawn to more of the research side of things, but you don't know what your interests will be like in the future. Or maybe you have strengths that you didn't know you had, but you just weren't before in a situation to use those strengths. So for example, like I have always been a researcher. That's been a huge part of my identity, but I didn't know that I enjoy building things until I started to build things. Like until I was forced to program a lot of my own analysis systems. And so now I'm really interested in more in doing more coding of my own, and not just purely research. So my advice would be to just be a generalist at first. Try to do everything, or try to learn everything, and use that kind of generalist skill set that you have to get a job in data science. And then within your job as a data scientist, explore different options. And the more experience you gain, and the more knowledge you have about yourself and what you're good at and what your preferences are, then you can specialize. That's what I would do. Mm-hmm. Okay, so a question from Arun. Can you comment on the ethics of making a recommendation when data isn't clear, one way or the other? Perhaps your employers want a recommendation, but the data may not indicate an answer. So perhaps a recommendation. I think I always say that prevention is better than a cure. So I think before you even get to a situation like this, it would be great to involve your stakeholders, like I said in the presentation, and make sure that you agree on your metrics. You agree on what recommendations are, what recommendations make sense and what recommendations are satisfactory. So yeah, I'm not sure if that answers your question, or like if you had a concrete example, maybe it would be clear, but
yeah, I mean, one of the reasons I was asking, is I think in many of the cases or many of the jobs that our learners will go into, the people who may be asking them may not be aware of the recommendation of the limitations of what's possible with the data that they have. So they may be,
okay.
so for example, like in the week 2 challenge, they might have said, the question actually asked for a recommendation and the data didn't give a clear answer one way or the other. And they may be asked to make a recommendation, but the data may not, there may not be enough data.
Okay, got it. I think that's a kind of a good argument for making, but of failing fast, if that makes sense. So make sure that you, when you are working already as a data scientist, to kind of you kind of come up with a minimum, like a kind of a MVP, that makes sense, as soon as you can, in order to iterate faster. So by that time, so for example, you're kind of stuck at something for about a week, and then you realize you don't have enough data, then you can spend the rest of your time just collecting data. And because it's in data science, it's easy to overpromise because there are a lot of exciting things that can come from data and data analysis and data science. So for stakeholder management, and to involve them in the process of designing your AI systems and your machine learning solutions. I think, yeah, I can't really think of a way around it other than having a good conversation with them and under promise and over what do you call it? Over deliver. Yeah. So.
Okay. I mean, just to add a comment from my side, I think that this is something that many of you will face when you go into the world of work. I think people who are setting tasks for you may not be aware of what are the limitations of analysis. So I think it's up to each of you to also make sure that you clearly say, what is the limitation of this analysis?
Exactly.
Yeah. So I think this session ended then. Let me stop recording. Yeah.